Okay, hello everyone. Welcome to the next part of design patterns. We have already covered the first part. You can get this part here. But so now let's talk about what else in design patterns. We have only covered few of them in the first part, but it was very interactive session for me actually. So let's start with the next question. The question is why Java.lang.runtime is a singleton in Java. So basically, it's because when you use a runtime, right? Runtime is it always acts as an interface with the environment. So basically, you need one to interact with the environment. So at that point of time, you need to have one particular person responsible for it because we have multiple things. Like suppose if we talk about runtime, it has methods called total memory and max memory. So as you can understand, total memory gives you the total memory in JVM, and the max memory gives you the maximum memory that the JVM can use. Similarly, there is an exit method. Similarly, there is a GC method. So all these methods are very critical. If there are multiple instances using this method, then you won't be able to get the proper like point or proper logic from it, right? So that's why we need a singleton pattern in this. So now the next question will be, what is the way to implement a thread-safe singleton design pattern in Java? So please understand carefully. I got this question a lot of time because sometimes the interviewer also knows that you don't use a lot of design patterns in the real life. Like you, if you have certain experiences with them, you might be reading a book or something, so they just want to dig deep into that, and then they want to ask you how and when you can break or make a singleton design pattern. So there are multiple ways, but we will be only talking about three types of it. So one is a double check locking. So double check locking is a tendency where you keep a check two times, like once you create a synchronized block, and then you, after that synchronized block, you also check if still you have an instance as null or not. So let us talk about this. So suppose there is a class called double check singleton, and you have a private volatile, say hello singleton, hello singleton. What is the use of volatile? We have already discussed in our Java interview questions. You can go and check it out. Okay, then you can talk about public hello singleton. That's a simple instance method. So here you are not talking about static because you are using a volatile. Now you have taken a hello singleton here. In that case, you go and check if your result is null. That means if your instance is null right now. Okay, because what you are doing, you are trying to get this particular hello singleton from into the result. So if your result is null, then you synchronize the whole block. Okay, now I will make it that no thread can go. But the problem will be two threads can actually check this statement at once time and go to this block. So now you actually go with this. If at result is still null, okay, then you go and create the instance. If result is not null, then you return the result. So suppose two threads come to this point before synchronizing, but after this block you will be synchronized. So one thread will go there and then other thread will wait for it. Or suppose other thread also goes there, then you check like which thread is actually active right now. Now the next part. Next part is called Bill Pug singleton. So what does actually it mean? Here we actually use a instance. Okay, here we actually use a instance. So if you can see, we create a public static final instance with a new singleton pug, and then we make our constructor private, and then we have a static method which will actually send this instance instead of the like normal object. So now what the problem is, one first time singleton plug is loaded into the memory, inner singleton is not loaded. Only when you call the get instance method, that time inner singleton class is loaded and the instance is created. Okay, so what does it mean? You will ask me, what does it mean? You are just read it and nothing else is happening. So it's basically once you this singleton pug, right? This is loaded into a memory. This particular class will not be loaded. This is an inner singleton class or static inner class. So once you call this method, then only this memory will be loaded, and the next time it will be used. Second is you can use enum to create it. So basically, you create an enum called instance, and then you do whatever the f you want to do. Okay, so now let's come to some of the examples of singleton design patterns. I'll just read it out because no nothing deep is required, as we have already talked about runtime. dot get runtime, which is singleton, got dot get security manager, dot get desktop, your session factory in Hibernate, and many things. So now let us talk about what is a template method design pattern. So as we know, template is like if you want to uh, like serialize your day, or maybe like kind of generalize your day, you follow a certain habit, right? So it's kind of a template. You follow a template. I wake up, I'll brush my teeth, I go to washroom, I'll come, I'll do my prayer, not prayer, I'll do my journaling. This is all high stuff. For us is I'll do my Instagram and all those shit. So not shit, okay, sorry. So yeah, all those things. So that's how it is. So we generally outline how the algorithm should follow, and then the other outline will be delegated with the steps of subclasses. Now what happens? How actually you can give example of it? Suppose we are writing a game, right? So any game will take care of certain things like initialize game, end game, and make a move, who wins, print out, and those things. So if you suppose there's a game called Monopoly, there's a game called chess. For them, you will have this kind of methods, right? Initialize game, make move, end game. Similarly here. So template method is very, very useful here when you know that what kind of things you have to provide, and other things you can always implement. But the main template you can always give, and so that to create any game which required multiplayer player and which required a kind of making a move, you can do that. So that is called template method. Now we will talk about our JDK implementation. So all the abstract collection classes like abstract list, abstract set, abstract map, it implement a template for their corresponding collections. Because if you have abstract list, what will happen? If you have an abstract map, what will happen? So like this. So suppose we come here. Okay, we come here, we go to some Iggly Wiggly bush, and we come here and we create abstract okay, list. Okay, and we don't know what is this, so we go here, we see protected abstract list. It has a add method, it has a get method, and it has set method. Similarly, then we have a boolean add method, and we have normal void add also, like where we want to add in the index. This is called an abstract, where we do you have kind of like I can say abstract, it extends abstract collection which implements the list interface. Okay, and you do all the like stupid stuff if you want to do, like this abstract e dot get, right? So you can actually have, this is an unimplemented method. So this is how you can do. You can go and check any methods in this particular section if you want. Now let's go to Java x.servlet.http servlet. So there we don't want it, because mostly we have now moved across using the REST template and all those things. Then Java input output package. There are stream and writer classes like input stream, IO output stream, reader and writer that also provide non-abstract methods. These methods are implementation of template method design pattern. So yeah, you can see non-abstract methods we have. Now let's go to the next question. Can you tell some examples of factory method design pattern? So suppose we can go to java.lang.class.forName. For name, it is a factory method design pattern. You can say the stream handler factory.create URL stream handler. You can also check calendar.get instance. Okay. Then you can take resource bundle.get bundle, number format.get instance, car set.forName, enum set.off. These are called factory. You can also take about this list of dot off, right? This is now new things called like this. If I know my statement will work, let us, that's called like a list of integers. Okay, L1 is equal to new list dot of. So see, this not works, doesn't work because I don't have a Java 11 maybe. That's why. But it's like it works a very good way. If you, I can explain you in some other example. What is the benefit we get by using a static factory method to create objects? So see, the best thing to use a static factory method is, and why we use it is because we encapsulate the entire creation process of an object. So what does it mean? So basically we always use new parameter to create an object from its constructor. So instead what we do here, we create a static method of a factory to create the object. So as we know, the main is like we are not sure that which new we have to call. Do we have to call a new something else? a new concrete cast, different thing like that. So we need to do a creation at runtime. We can't decide without prior noticing, right? So that's why we need to have a method which can call. Like if you take example of a shape factory, so in that case, you know which shape you want. If you want a circle, it's not a circle, but yeah, if you want a rectangle, if you want a square, if you want a particular cube or something like that. So it all depends, right? So you will be calling those methods, which will be taking care of which particular class you want to invoke in the shape factory. So this is how it is. Now let's talk about a JDK example. So you know in a connection pool, we can always limit the total number of connections that can be created, as well as we can hide the implementation details of creating a connection. So we can always go and that connection bool dot get connection. He can go and get the connections. He don't want to create and do all those things. That's a good example, right? So now let's talk about a builder design pattern and we can stop it right here. So the question is, what are the examples of builder design patterns in JDK? So the builder design pattern is used to build anything. Suppose you have something like a building, right? You put something on top of it. So the best thing, if nothing is coming to your mind, you can come to say, hey, string builder. String builder is a based on builder design pattern, right? Then you can call int buffer dot put. So it always returns the int buffer method, but you don't need to do lot of research on this because these are now like totally things which are gone now. So we will just talk about this guy. We have Lombok right now, which can actually do all the add the builder and all those things. So yeah, the appendable is there. This thing buffer append again. I don't know why these things always go with the same thing. So, but it is here for string buffer. So append function is there which can use. And I think I talked a lot, and I think you have listened a lot. So we will stop this particular recording here. Please let me know how you liked it. If you have liked it, good, do give it just some thumbs up. Try to share with your friends because it's very extremely important that this series gets started and ended also. And we have just reached very like I think we have still many more things to come, and these things will keep on continue. So have a nice day and thank you.